Hi everyone, welcome to my channel Code with Ease by Varsha. So, just as every failure is a stepping stone towards success, similarly, every mistake that you have made as a developer in the past is also a stepping stone towards you being able to write the right code. So, the better you are able to write the right code, the better you will become at reading and understanding code. And very soon, let me tell you, very soon, you're going to be one of the most favorite code reviewers in your team, in your company, eventually if you learn from the mistakes and try to apply them, try to implement them in your regular coding. So, on that note, we are going to cover today the 15 common mistakes that we do usually while writing code. And how can we not do that? What can be the bad practice and what is the good practice? We'll compare that. And yeah, with that note, let's begin. Okay, so starting with the first idiom that we have, invoking equals on a string literal. The first idiom is invoking equals on a string literal. So if you see this particular example, we have this order of comparison where str is being compared with the literal hello world. What can happen? Why is it a bad practice? Because it can throw a null pointer exception. Because if your str by chance, if it turns out to be null, so if you try to invoke any method on top of null on a null, like we do null dot something, it is going to result in null pointer. So what do we do to fix this? We have to reverse the order of the comparison. So this is how is the right way, the right practice to do a comparison is this. You put the literal on the left hand side and in the RHS in the right hand side, you put the variable, which is the unknown, because we do not know what is going to come in with the variable. And even if, so with this, there is no risk of NP. And even if str is null, the comparison will simply return false. Next is var args or variable args. So if you see this particular code example, we have a calculate sum method which is taking 3 arguments. What if I have a method which takes in variable number of arguments and hence the name? This is the bad practice because we do not know how many number of arguments will be there. And we cannot, it is not a good practice to write so many different overloaded versions. So what do we do? What is the good practice? The good practice is to use variable args with this. So you use the data type that you want, like over here we have int and we have 3 dots. This is representing the var args or the variable arguments. So this numbers which we have over here can take in any number of parameters. Doesn't matter. It can be 1, 2, 3, x number of parameters. So how var args are actually working under the scene is, so the type of data type that you're passing, like you're passing in, automatically under the hood, an array of that type is getting created and all the numbers that you're passing, X number of numbers are getting passed into that array. So there's an array that is getting created and under the hood, that array is being managed and all the numbers are being passed into this. So you'll be like, why not us create an array? Of course, you do not have to manage the overhead of creating and managing the array, which is already Java is doing that for us. So instead of us creating an array and managing it, we just specify the data type, 3 dots and the variable. Anything else that you pass in, X number of variable number of arguments that you pass in, that is being treated like an array of numbers and handled accordingly. Avoid using null. So usually we use null to represent a missing data. Now see this particular example. Many a times we do some method invocation and we do not know what the method is going to return. Let's say this particular name is null and the length that we have over here, since it is null, again, we are doing a method call on something which is null. So when you do a method call on something which is null, we know that NP can occur. So that is why this is not at all a good way to represent, this is not at all a good way to fetch data from something which is unknown for us. So what is the good practice is to use the good practice is to use an optional class. I've also done a detailed video on Java 8 optional with hands-on code demo with 10 different code examples from scratch on how to use Java 8 optionals. I'm going to link it in the description and maybe you'll also get it in the I button above. So we have to use optional class which will indicate whether the value is present or it is not present. So if you see, we are defining an optional dot of nullable. If it is present, only then I'll do dot get and then I'll get whatever value I want to get, like the length in this case. Otherwise, if it is not present, it is like a container which is going to tell me whether I have the object or I do not have the object. If I have the object, great, I'll use it. So I'll use it. If I do not have the object, then I'm going to handle it accordingly. So it will just give me name is done. We are using optional.nullable to create an optional instance. And these are the methods which we can use to safely access the value. Utilizing constants. So you might have seen many times when we write code, we use some different, we use constants, we create a different file also. That is a good practice to create a constants file and we put all the constants over there. But if by chance you do not use, or if you see in places it is not being used, then there is a term which is called magic numbers. And this is such a big red flag whenever code reviews are done, that there should not be any magic numbers. So What are constants? The values that do not change. You already know that they're not going to change. So if they're not going to change, you should not be hard coding any value like we are doing over here. Value greater than 100. What if it is tomorrow it is 200 or it is 300? So you shouldn't be doing this because of all the issues that is going to happen. How should you use it? Define a constant file, or you can define it like public static final. If there is just one variable that you want to declare as constant in your same class, you can do that, or declare a constant file. And this is how we represent it. This is a very basic thing that one must know on how to use constant, where to use it, and why to use it. And the most important benefit is it becomes centralized. It makes the handling of the constant values also very easy, that you only have to change in one place. Otherwise, let's say you forget to change in one another place where it was already being used, it is going to create a massive trouble for you. Now, the question is, why are we using public, static, final? Public, because of course, we want to make it accessible across classes. Static and final. So static final is used because it improves the performance by avoiding unnecessary memory allocation. So that is why we have to make it static, because it will be shared across all the variables, class variables. And to keep the value constant, we use final. So this is also one thing which you have to understand. Public, static, final, all the three keywords needs to be used. Public is of course a modifier, static and final. Checking wait condition in a loop. So this is a typical wait notify scenario in a multi-threading environment. Although I have done so many different videos on wait notify all, and on multi-threading, of course, there are several different playlists on that where I've discussed about this also. So the ideal typical case is there is a synchronized block, and then there are multiple threads, right? So one thread is trying to call the wait method based on some condition, and another thread, let's say I'm giving a very simple scenario, and one thread is calling the wait method. So until this particular condition is not satisfied, like the task is not completed, it will keep on waiting. And then another thread will be like, okay, I have done the task, so it will try to notify. So it will notify this thread, and then it will wake up from its waiting state and resume the work. So this is a typical flow of what happens. So if you notice this particular code, everything is in place. We have not included the code for notify, but there's another thread which is doing the work of notifying, doing the task for which this thread is waiting. The problem is this if condition. Now let's say the thread, without even getting notified, if it wakes up, that leads to a condition called spurious wake up or fake wake up. It was not supposed to be woken up, but it got woken up. So that can happen due to many different reasons, like some platform specific, JVM specific thing, thread scheduling. There can be many different reasons. But if that happens, it will lead to data corruption, inconsistent behavior. Like you were waiting on some condition, and even if the condition is not completed, even if the task is not completed, the thread has woken up, it will incorrectly assume that the task is done, and it will carry on the execution. So that is something which we shouldn't be letting it happen. If the condition is checked only once and this happens, thread may proceed without the condition being truly satisfied, like I said, leading to errors. So what should we do? Only thing we have to change is this particular condition. We have to put it inside a loop, so that when it is inside a loop, we are ensuring that this condition is rechecked. And even if there's a spurious wake up happening, the condition is not incorrectly being satisfied. So we put it inside a loop. So until and unless this task is actually not completed, it is still going to be in the waiting state. To recheck the condition before proceeding. Next is string builder or string buffer. So what is the bad practice around it is, if you notice this particular loop, some string concatenation is happening within this for loop for n number of times. Here it is 1,000, it can be million times or whatever, and we're doing the string concatenation. In this case, this is not the good practice, because strings are immutable in nature. So whenever you're doing this concat operation in the Java heap, okay, this is leading to a new string all the time. So what happens is, let's say you're appending s plus s. So now this is one string. Now again, you're saying this s plus s is causing, let's say, t. Now with this t, you're adding another s. So this string is actually discarded. And now your reference variable is pointing to this. Similarly, it is going to point to new strings. So in the heap space, again and again, new strings are getting created, because you cannot really modify an existing string. This is a very basic concept of string constant pool. Okay. And excessive garbage collection overhead. So this is a very, very bad practice which you shouldn't be doing. So that we have classes for that. We have a string builder class. This is the right way. So whenever there's a heavy concatenation happening, always we should be using string builder. And where is string buffer coming in? So string builder is mutable. We can modify the contents without it creating so much of overload of too many strings getting created in the heap space. And where is string buffer coming in? So if you have to take care of this mutable, immutable thing, like unnecessary, you do not want the overhead too much, and also you want that to happen in a multi-threaded environment, then you have to use string buffer and not string builder, because string builder is not thread safe. String buffer is thread safe. So you have to use string buffer in that case. So it is similar. It provides a synchronized method. String buffer provides a synchronized method. That is why it is making it thread safe, right? So the next is using enum as singleton. This is a good practice that we should use enum as singleton. But let's talk about what is the problem with this particular code. So singleton is a design pattern. What happens is the class should have only one instance. There should only be one instance, and it should provide a global point of access to this instance. This is the core of the basis of the singleton pattern. And to achieve that, there are so many different flavors or so many different things that we have tried to achieve. This particular code is trying to show the eager instantiation pattern, where even before the object is being used, the instances is being used, we are trying to instantiate it during the class loading phase. So eager instantiation, the problem is we are consuming resources. There's a resource overhead. Even before using it, we are creating it. So that then it led to adoption of another type of singleton pattern, which is called, it is called lazy initialization pattern. Okay, where we will do this late. So not at the class loading, but we will do it over here within the get instance method by doing some null check. But even lazy instantiation had a story of the limitation of lazy instantiation was it is not thread safe. So to get that thread safety, we had to introduce another this, like we have to modify this method where we could use synchronized keyword or maybe use double check blocking. That also had performance overhead, because we know that due to synchronization there is a additional performance overhead. So with all that, we have seen that with singleton pattern, in order to implement it, there are so many different aspects, so many different types, but each of them have their own limitation. The simplest way to do that would be to use enums. So as we can see over here, when we are doing it eagerly, it doesn't provide flexibility in controlling all of that, which I've already told. So what is the best way to do it? To declare it as a enum. Enums are inherently thread safe. So enum constants, they're inherently thread safe. They are singleton instance. They will only be initialized once, even if it is a multi-threaded environment. So firstly, the global point of access problem is solved. Thread safety is solved because JVM is going to enforce the singleton behavior. There is no need of any custom code to handle the lazy initialization part. So thread safety is done. Global point of access is also done. And you also have one instance which is being shared. And it is also very simple and easy to implement. Simple and easy. So enum is going to get solve all the problems that we have faced earlier. So that is why it is recommended to use singleton. But the only limitation of using enum as a singleton is if you need inheritance, that is not possible. If you want to inherit it, the base class child class relation, that will not be possible if you want that with the singleton instance. So that is the only limitation. But in every other case, using enum makes more sense. So this is a very popular one. What is the bad practice over here is we're using trycatch and we are closing the resources that we have opened for the IO stream in the finally block. Okay. Why is it a bad practice? Because the resource management is pretty verbose and cumbersome. When we have and it may also lead to resource leaks or improper exception handling if it is not correctly done. Like if you can see, there are a couple of lines of code which we have to do to clean up the resources. If there are multiple resources, again, a lot of different lines. Intricacy is getting increased, and complexity, overall code complexity is getting increased. So we shouldn't really be doing this when you're working with IO streams. Rather, the best way is to use try with resources, as we can see over here. No finally block. Whatever you're doing with the buffer reader, you enclose over here, do the logic and have the simple catch block, the try and the catch block. There's no need of any finally. The buffer reader is declared and initialized with the try with resources. And the best part is the resource is getting automatically closed at the end of the try block. So your JVM is taking care of this, and that ensures proper cleanup without us explicitly mentioning anything in the finally block. Iterating over hashmap using entry set. So if you look at this particular code example, it might look normal. There's a hashmap. We are using a for each loop and we are looping it over it. if you notice, there's a hashmap.key set, and then inside this, we are retrieving the value. So, like right, if a map is there, there's a key and a value. So we are iterating over the key set. Key set as in it is a set of all the keys of the map, K1, K2, K3. So first you're creating a set of all the keys. And then based on each key, you're trying to get the value. So what is the problem of this? The problem is you're doing two hash lookups, which is going to overall degrade the performance. How will it do this? Let's try to understand. First, you're trying to create a set of all the keys. That is one lookup. So how does it look like is you have an array of buckets, right? So the internal working of hashmap I have also covered. So you have, let's say, a couple of indexes. And at each index, you have multiple key values. KV1, KV2, or in some cases, if there is a hash collision, you will have a long chain of key values. Now, first lookup is to aggregate all the keys in some set, in some data structure, which is fine. You're doing one lookup. Next time, for every key that you got, now you have to calculate the hash code of that key. Then you have to find out in which index it is, go to that index. Then from that, you have to find out what is the value over it. If there's a hash collision, you have to find out there will be a long linked list, a chain of nodes. You have to traverse through the linked list, which is going to give you a time complexity, a worst case time complexity of O of n, because you have to traverse through the entire linked list to find the value, what you need, which is associated with that particular key. So there are two hash lookups that is happening. And it is completely unnecessary because if you need both the key and the values both together, there is a better method that you can make use of. Why do you want to first get the keys and the first lookup you're not even accessing, you're not even using the values, or you're not even capturing the values there itself, you're just taking the keys. So the best practice is to use entry set method, where together you'll get all the key values in one set, all the key values like this. Now you traverse over this set and you just do, you want to get the key, get key, or you want to get the value, you do get value. That's it. So this is the best practice that you should be following by using the entry set method and using this map.entry object, which we are using over here. Map.entry signifies every entry that you have, and that will contain the key and the value of every map. So it's like containing all the mapping of all the entries that you have in the hash map. So what is the problem with this code? We have a for loop traversing over this particular list. It can be of any type, array list, linked list, and we are trying to get the value out of it. This is a for loop which is trying to take the index, and you would say that is the problem. Why? Because list, let's say if it is an array list, which is backed by an array, underlying array, and in case of array, we know that there is contiguous memory, like the elements are stored in contiguous memory locations, giving us random access. And in order to access it, we will get a time complexity of O of 1, constant time complexity. But if it is a linked list, on the other hand, they are not stored in contiguous memory logs. So in order to just locate it by the index is going to take me O of n and another O of n, because we are looping through the list. So O of n into n is n square. So because we are changing the type, the implementation, we are easily downgrading the performance just by changing the type and using the same code. So that is why this is not the recommended approach, because of the poor performance that it is going to give us as soon as we change the type. So any data structure having non-random access for this kind of thing is not suitable. So what do we do? Another problem is thread safety is a concern when we are using a code like this. So what do we do? So when we use an iterator, it helps us to achieve sequential access to the elements in the collection, and it goes in the forward direction, helping us to traverse through each element of the collection one at a time, irrespective of the type. That is the important thing. So doesn't matter if it is array list, linked list, or whatever data structure, irrespective of the type, it is going to give us a sequential way of accessing the elements. So same behavior will be exhibited. Doesn't matter if it is a random or non-random access. And also on top of that, it is going to be thread safe. So in case of multi-threading scenario, also we are safe to use iterator, or we should be using iterator rather. Now this particular code will look very simple, and many of you might neglect and overlook also. What is the problem over here? What are we trying to do again and again? The input.length. So if any computation, which we already know that it is going to remain constant, the length of the list or this particular string is not going to change. So this is adding unnecessary overhead because you're trying to compute it again and again. So what can we do? We can take it outside. I think this is one of the potential time complexity issue which happens in lead code question answers also, that oftentimes we try to not use the length variable like the constant and use that constant, but rather we do the computation within the for loop. Like it happens very organically that sometimes we will forget, we overlook. So that is why it is something which we have to be very mindful of keeping this constant things outside of the for loop. Anything which is constant, not just the length, anything which is constant to be outside the loop. Next is using switch case over if else. So if you look at this, a very classic example of using switch case, the problem is you do not have to do this multiple if else, especially if the condition is just as simple as checking one particular equals, using equals to check a particular field. But if it have been like a very complex kind of a query or a condition that you want to check, then maybe if else would have made sense. So if each condition is getting evaluated sequentially until a matching branch is found. So else if like that, which is inefficient. And if you have a lot of branches, this is again going to take a performance hit. What should we do? Use switch case, which are optimized for multi-constant selection and provide better performance. Why switch case is better than if else? The reason is they're using lookup tables. Like we have hashmap lookup tables. They help us that, okay, if it is a Tuesday, I will directly go to this particular case. I will not even look at the case of Monday. So it is like directly going to give you a constant time complexity. That is why switch case is preferred for these kind of scenarios where it's just a constant kind of a check that you're doing. So another mistake is a very old school way of using this add method to add elements or initialize collections. Add method, put method, whatever. So whenever trying to add elements to this particular, like add elements to list or set, whatever, we use something like this. Very old school, very traditional way of doing it. But we have better methods. We have arrays.asList and we have list.off. So why is this not good? That first it looks very verbose, it's repetitive. You have to do it manually. You have to remember to add all the elements, but you can do it in single line. You're wasting lines also. So you can do it in single line, something like this, by using arrays.asList and all the numbers. And this is a very good application of the thing that we learned about var args or variable args, that this implementation actually takes in the variable args, which is why you are free to pass as many number of parameters as you can instead of writing add like that. Or this is going to return actually an immutable view of the list or the set, whatever you're using. So be little wary of using this set.off, list.off. It's going to be immutable, so you cannot really change it. In this case also, you cannot modify the size. Once you create this, you cannot modify the size, but you can modify the elements of that list, what is going to come out of it. Another mistake, so this is a very common mistake, again gets overlooked, that we prefer using the concrete classes of the implementing classes more than the interfaces itself. So if you see, we are returning hash map of string and integer to get the word count map. And again, we are passing in the hash map to initialize the word count map. Why are we passing in the hash map? Because it seems convenient, easy for us, that we know it is a hash map. But what if tomorrow it is no longer a hash map, it is a linked hash map, or maybe it is a tree map? We do not know. So in those cases, it is not a recommended way to use the implementing classes always, because it makes us more tightly coupled. So there is one of the solid principles, like, right, that it is called open closed, that your class should be open for extension and closed for modification. So if I want to change the implementation, I should be having it as map and not hash map. Tomorrow, if I want to change the implementation, I should come over here and change all the occurrences of the hash map. So that is what I was talking over here, the solid principle, the open closed principle, the O of solid. So what is the right way to use a map? Use a map, use a list. Don't use array list only. Don't use linked list only. Just write list, or just write set, or just write map. Use the interface. So this is how you can use the wildcard generics, enhances the flexibility, blah, blah. So yeah, that is what we covered. Prefer primitive types over wrappers. This is boiling down to the concept of boxing and auto boxing. So if you see this particular code example, the total price is being stored in a wrapper class called double, whereas the computation that we are doing over an array of prices, which is a primitive double. primitive integer double type. So just for the summation, we have to do the constant boxing and unboxing, like converting from the wrapper type to the primitive type and primitive type to the wrapper type. Again and again, we have to keep on doing that. So, which is going to consume additional CPU and memory, performance overhead. Everything boils down to performance overhead. Most of the things boils down to performance overhead. So what should we do? If you're using primitive type and doing the computation, use the primitive types only. If you're using wrapper classes, use the wrapper classes. Don't try to switch between each of them, especially when you're trying to do some computation.